Hey, Serverless friends. Welcome to another Azure Functions University lesson. This time I'm going to talk about calling third-party REST APIs, and I have Maxime here to help me with that. Hey, Maxime, welcome.
Hi, Mark. Thanks for having me. How
Yeah,
are you?
I'm doing very well. I'm looking forward to recording another lesson. I'm pretty sure lots of people are also very keen to learn about calling third-party REST APIs. So yeah, thanks for joining. Would you mind sharing a bit about yourself?
Yeah, sure. I'm a computer scientist. I've worked for like 22 years in the Microsoft stack. So I enjoy working with Microsoft technologies. And lately, I've been doing a lot of cloud technologies. And that's what led me to work with Azure and Serverless, so Azure Functions in particular.
Nice. Yeah. And what do you like about serverless?
Oh, I like that you can quickly set up an API, basically. And I also like the fact that this makes it very easy to use event-driven architecture. It's not exactly event-driven, as the name says, but you react
Yes.
to things, to stimulus, to notifications, and then you can do a quick and easy processing on that event. So I like that.
Cool. Yeah. No, I full-heartedly agree with that. Very nice. All right. So before we dive into the lesson, let me quickly share my screen and let's talk about the Azure Functions University repository. If you follow this link, it will take you to this GitHub repository. It contains a lot of lessons, also across a lot of languages. So it started out with .NET Core, but now we are recording .NET 6 lessons, but there are also TypeScript lessons and PowerShell and Python. And the number of lessons is still increasing and increasing. So please have a look at this repo. Also, if you would like to contribute to this repo, you're more than welcome to do so. Definitely always looking for people who want to contribute lessons. And even if you're fairly new to serverless, I'm happy to help you out with this. All right, I'm going to switch over to you, Maxime.
Thank you very much. So, Mark, you contacted me on Twitter. You just threw a bottle in the sea and said, "Oh, who can contribute to this open source project?" And I found that it was a fantastic opportunity to teach people. And as it happens that I need to teach my coworkers, I said, "Okay, let's do this."
Excellent.
And so the lesson I'm talking about today is how to call third-party REST APIs, and we are going to use .NET 6 for that, of course, in Azure Functions.
Mm-hmm.
Of course, the goal of this lesson is to learn how to call REST APIs, but in particular, I wanted to focus on using HTTP client. And why is this a problem at all? Because HTTP client is very well known. It has been around in the .NET framework for a very long time, but it has notoriously been difficult to use it efficiently and correctly. The original designers of the .NET framework made HTTP client a disposable class, meaning that if you were following the guidelines, you were supposed to instantiate an object every time you wanted to call an API, and then you had to dispose of this object afterwards, perhaps using the using statement. And this has led to many anti-patterns, wrong usage of the HTTP client that has been very long to fix. Among the problems that you have if you do that is that you are quickly using a lot of sockets under the hood, so network connections, and computers have a limited amount of sockets that do not get closed immediately after you dispose of the HTTP client class. So that's what makes it difficult to use it correctly. Of course, people knew about that and created some HTTP singleton factory to make it easier to use. But that leads to another sort of problems, although very rare. But it can, for instance, not react immediately when the DNS changes and other phenomena.
Ah, right. Okay.
So starting from .NET Core 2.1, actually, Microsoft set out to create a new set of abstractions to make it easy to use HTTP client in an efficient manner, and that's what we are going to use today. For this, I would like to focus on one particular library that you can use, which is called Refit, which makes it very easy to create strongly typed abstractions over the HTTP client. So if you'll allow me, let's dive in.
Yeah, definitely.
The lesson assumes that you have somehow followed the original HTTP lesson from this repository. So I'm going to quickly redo the steps. I've got a blank canvas here in which I will do the lesson. So if that is a bit too quick, please feel free to review the previous lesson. But that will serve as the basis for exercise number 1. So exercise number 1 is just to create a default HTTP triggered function with the project template that Visual Studio Code comes with. So of course, with Visual Studio Code, you've got all the tools ready to use. So I'm going to create a new Azure function. So it says that I want to create a new project, which is okay. We are going to use C# for that. And as you recall from the previous lesson, we have to change the Azure function runtime to v4, which is the new runtime that supports .NET 6.
Yep.
We are going to use .NET 6 isolated for this lesson because it makes it easier to abstract away the runtime to your actual dependencies in your code. And of course, we are going to use an HTTP trigger that is going to be called hello world. HTTP trigger. So hello world.
Hello world. Yeah. Okay.
And to keep it in line with the previous lesson, we are going to call this isitfuncuni.http as the namespace. So I'm going to use the function access rights, which just says that we need to add an extra query string when we host the function on Azure. So the project is generated automatically. And when you've done that, you can actually build a project, Control-Shift-B or Command uppercase B on other platforms, I assume.
Mm-hmm. Yep.
And that's it. So I'm going to quickly review the files that have been generated, but you can see that basically you've got a program.cs that is the new main from the .NET 6 template. Mm-hmm. So it just says, it creates a host and it runs, as simple as that. And the bulk of the logic that we will be interested in today is in the hello world HTTP trigger.cs function. So this is just a regular class, and it has an attribute. It has a method which is decorated with an attribute, and that's what says that it is an Azure function. And the default template comes with an HTTP triggered function that accepts get and post verbs, mm-hmm. and just responds with a status code 200 OK with whatever has been passed in. Sorry, it responds with welcome to Azure Functions with a default text.
Yeah. So
let's just quickly build this, and we will test this right away. So as this repository advises you, it's best if we use the REST HTTP client extension from Visual Studio Code. So mm-hmm. I'm just going to create a new function, a new file here, local tests.http, and the HTTP extension allows it to recognize the syntax in between the 3 hash-bound signs. So my function is being built, and I think maybe I think it should. Yeah, I think it's ready. Let's send the request, and I get a 200 OK with welcome to Azure function.
Yep.
So this means that the first setup has been made, and we can now improve on that. Okay. So the second step, so let's see the exercise one. So the exercise one was just to illustrate what I did, to create a new project with the Visual Studio Code and to test that it actually works.
Exactly. Not yet calling any external APIs just yet. No.
Exactly. So now we are going to do the real work.
Mm-hmm.
So for illustration purposes, I chose to use the httpbin.org API. So for those who are not familiar with this API, it's just a website that is publicly available and that you can use to test various conditions. You can use post, get, and any kind of verbs. Actually, you can control what you send. You can control what you want to receive from this website. So basically, if you were to call it like http httpbin.org /status. So that's one of the routes that exists. You can say, okay, I want to receive a 200 status code. And indeed, you retrieve 200 status code. And of course, you can say, okay, now let's say I want to receive a 404 to know how my client will react to such responses.
Exactly.
And so indeed, you receive 404. So it's very easy to easy to test. And of course, you can also one of the API that we will use is the post /post route, and this one allows you. So it's called post, and it expects to receive a body like let's say we're going to have a content type text plain. Sorry about that, and we'll say welcome to Azure Functions University. Of course, you can also add query strings like hello world.
Okay.
And if I send a request, I get so httpbin.org /post. Yep. This should be it. Okay.
Hi.
And this allows you to control what you send. And in particular, what I would like to focus on today are three things. So you can see that the body of the request is in the data field of the response. The query strings are somehow parsed into key value pairs in the args JSON object here.
Yeah. Nice.
And of course, you've got the headers that happen to have been sent as part of the request. So that's what we are going to use today as our API, basically.
Yeah.
All right. So just to make it extra clear, I'd like to just highlight what we are going to do with a small illustration. So basically, what we are going to do is to call an httpbin.org API. And for that, we are going to use an interface. An interface in C# is an abstraction over some kind of implementation. Of course, in the distributed system world, the HTTP bin is an API, and so it sits at the other end of an HTTP network.
Yeah,
and
it's
that's
not an
what we
Arlic
are.
machine, so it's someone else's
Exactly.
machine. So yeah, okay.
Exactly. So I think what is also important to understand is that this interface is actually will be implemented by Refit, which is the library that we are going to use. So the library that we're going to use is using the HTTP client class under the hood, and it also adds a lot of strongly typed infrastructure to actually make the call. And so that's what we are going to use. And so we will come back to this in a little while, but now let's dive into the code.
Yeah, excellent.
So the first thing to do, of course, is to define what we want to have as our API. We need to tell it how is the API looking on the other end. So I'm going to use an HTTP folder in my solution to host all the code. And I'm going to create an HTTP bin, okay, let's say bin org api.cs file to make this API.
All right.
Of course, I can copy this code real quick, but you can see that it is actually using the refit NuGet package, so I need to install that myself. So let's quickly do that. Package refit. I think that's it. I think we have it in.
I think the link was in the yeah. I
Yeah.
can see it there. Yeah, the link is there. In the first step. Yeah.
Client factory. So this will make the namespace is recognized and the attributes as well. So as you can see, we have a get attribute and we've got a post attribute, and I've chosen only to surface the two APIs that I've talked about, but httpbin.org comes with many more.
Cool.
And the one that we are interested in is the /post request.
All right.
So here I've chosen to just return a plain old HTTP content, which is a generic vanilla kind of object that you can use to retrieve the status code and the content, everything.
Yeah,
So,
the entire output that we saw also when you
exactly.
make the request using the REST client, right? Yeah. Okay.
Exactly. So now let's do this. So we need to also use dependency injection. Because this is an interface, it is best injected into the constructor of our class. So for that, we need to have a bit of setup here. So what we are going to do is we're going to to add a constant that represents the base address of the API.
Yeah.
And we are also going to use a method that configures the code. So let me just show you real quick. This is just copied and pasted from the lesson. And what does it do here? It says that I'm going to use add HTTP client, and this is a named client. And although we're not going to use the name, sometimes you can use the name for other purposes. And this will configure the internal HTTP client instance that Refit is using under the hood. And the add typed client is actually what wires this configured HTTP client instance to a proxy implementation of the interface. And that's what is going to be used internally. So I'm using the shortcuts from Visual Studio Code to automatically add the using namespace declarations, but you can use them. You can, of course, type them yourselves. And once we have this method, which this particular signature, we can, of course, inject the code inject the interface into our code. So we need to change that a bit.
Yeah,
so
because you actually have to call that, right? Yeah.
Exactly. So I'm going to replace this code. This code with the actual implementation here. So we have, okay, does it build? I think it does.
But the build is already called on the builder, right? So is that
builder
build? Is that even required?
Okay, the build shouldn't be called here.
Yeah. Okay. Right. Yeah, that's okay. That's it. Perfect. Yeah.
So I think let's go. Now that we have this, it makes it very easy for us to inject an instance of the HTTP client. the HTTP bin org API that I like to call client in my programs. And of course, we need to inject here in the constructor. So let's say we've got client, and we are going to initialize the field client automatically. And then we can modify the code now. So this code will be completely is completely useless for us now. So what we are going to do is, so I'm not going to write the code. Let me just copy and paste, and we'll explain what we have in there. So
yeah. Oh yeah. Okay. Right. Exactly.
So is this okay? Okay. One extra. So what do we have here? We need to, okay, so because this code is now using await, we need to use the async task keyword. So we're not returning an object, we're returning basically a task, and we
need to include which task it's using. Yeah. All right. Yeah.
Okay, so I think we're good.
Good now, I think. Yeah.
And so what does it do? So it accepts a GET and a POST request. It starts with creating an empty response with assumed 200 OK status code.
Okay.
And then it goes on to call the GET request method from the HTTP bin org API interface that we've created. And this returns an HTTP content object. So from this, we use the read as string async method to retrieve the content of the response that we just write to our caller. So basically, we've acted as a proxy to HTTP bin.org API from our caller standpoint.
Yeah.
And because Refit may raise some exceptions, we need to catch them to make sure that we capture the error codes, and we write that as well to our callers.
Yeah, and we update the status code to not return an OK when there's in fact an error. So that makes sense. Yeah.
Exactly. So let me just real quick try to see if I've got some sample code here.
So I think the interesting thing here is that you've defined that interface with these two methods, so the status method and the get request method, but we didn't actually need to write the implementation for that interface because Refit is automatically doing that implementation for us.
Exactly. You've got some generated code that is embedded automatically when you compile the application.
Yeah,
so I'm just going to hit the F5 run option here and reuse my local tests.http file to make sure that I have a new sample here, just to make sure that I can call this new function.
All right. Yeah.
So the function is running. Let's call the function. Yeah. And now I've got the 200 OK with a response.
Oh, yeah. Yeah.
Okay.
Nice.
If you pay particular attention, you can see that none of the query strings nor the body were sent.
Yeah.
And of course, that's absolutely that's of course obvious because I didn't do anything to pass extra parameters to the method.
Right. Yeah. We're just calling the method but not providing it with anything.
Exactly. So I need to do that, and that's the purpose of the following. The remainder of the lesson. If we review what we've done so far, that's what we've done. Is the outcome expected? Not quite. I mean, the outcome is missing the query strings and the body. So that would be one area to improve. And so that's the purpose of the next exercise.
Cool. Yeah.
So let's go to the next exercise now. The next exercise is twofold. The first thing we need to pass is the query string, and the second thing is the body. So Also, we need to use the first step that we are going to use is to use a more meaningful response type, because HTTP content is just a generic class, and sometimes your APIs have strongly typed structures, so it's best to mimic that using strongly typed classes. So let's use that. I'm going to declare a new class here, which is so because this method is called getRequest, and I want to strongly type the response, I'm going to call my class getRequestResponse.
Okay,
It's a bit redundant, but sometimes it's clear either way. Okay, so what did I say here? I wanted to say in this typed response that I'm particularly interested in the args query string dictionary, which is a key value pair.
Right. Okay.
And of course, the data, which should contain the body of the request. And of course, the headers, just to make sure that we have everything.
Okay. Yeah. Yeah.
So that's our response. So what we can do here is change the return type to a get request response object instead of a HTTP
generic one.
content.
Yeah. Right.
So because we've done that, we will need to adjust slightly the code for the HTTP, the hello world HTTP trigger class, because now the content is not an HTTP content object.
Of course,
it's actually a get request response object. Right. So I think the best way to do that would be to say, okay, so this is going to be the result, and the result is going to be read as JSON. So we're going to use, result dot. Oh no, sorry. So we've got our result right away. This is a get request response object. It has been automatically deserialized for us.
Yeah.
And what we can do now is return that to our caller. So we would have to say content type application JSON and write as JSON async, but because write as JSON async already does write as JSON async, and we're going to pass the result back to the caller directly.
Yeah, you don't even need it. Yeah, okay, because it already instructs that the output type is JSON. Right. Okay.
So let's quickly build that and send the call. Make sure that we didn't break anything. And the next step, we will be able to actually add those extra parameters.
Cool.
So the function is building, it's running, and now I'm going to use the local test HTTP call again to send the request.
Yeah, it was a bit too soon, I think.
Yes.
Yeah, now
it's just a bit too soon. That's right.
Yes.
So you can see that compared to the HTTP content object where we had all the parameters, we only have now the ones that we have declared in our strongly typed object.
Yeah, only the
namely,
args,
we have got the args, the data, and only the headers. And we've got nothing else. But that's fine for us. Still, we don't have the args and data, so that's now the purpose of the next step. So the first step that we are going to do is that we are going to add parameters in the interface to accept the query strings. And the query strings, as I said, are best typed as an I dictionary. So I'm going to use an I dictionary of string. So it's a key value pair.
Right.
And it's also going to be, I like that, but why doesn't it? Okay, maybe I should use something like using system collections .generic, and it makes it easy for me to not include that.
Yeah. All right.
of course, I need to add a new attribute that refit exposes so that it knows that this should come from the query strings themselves.
Okay, right. Yeah, so this is an instruction. So refit knows that to fill the query variable with whatever is in the query string.
Exactly. Now, the next step would be to actually specify those parameters here in the hello world HTTP trigger. So it needs a query here. But how do I pass the query given that I've only got an HTTP request data object? And that's where you recall what's been done in the previous exercise. So basically, you have an HTTP utility class that you can use to extract the query strings from the request. And once extracted, we will be able to specify, to supply them to this request. So I'm going to use this from the lesson here. And HTTP utility class lives in the namespace system.web. So I'm adding that at the top of the file. And toDictionary is an extension class that I would need to write for that to work, because here I've got a named value collection. I don't have an iDictionary implementation, so I would need to adapt that. So let's do this real quick. Maybe I can write that, or do you want me to copy the code?
It's fine if you just copy the code. I mean, So you need a bit of code to translate from one type to another type, and you have written some bit of custom code to do that. And it's useful to do it in extension methods.
So going to create a new folder, extensions here, and the name value collection extensions. Static class will contain the code that is needed to actually convert the name value collection into an iDictionary string. So it uses the this keyword, which makes it as if this method were originally present in the name value class, but it's just using public methods from the class to do its job.
Yep.
And that's how your toDictionary now works.
Yeah, now it works. Yeah. Okay.
So the GET request, we need to specify the query strings, and that's it. So let's build that and see. Oh, I haven't actually stopped the previous instance.
Okay.
Control C here. And we will build that.
Yeah. All right, so now we expect at least that the arguments that we are passing into the function are also echoed out in the response, right?
Exactly. So we should have an object which contains, result, which contained whatever has been passed in, and if it has been recognized by HTTP bin, it will return them to us.
All right.
So I'm always using the same request. Maybe this time we've got the args.
Yeah, nice.
So that was the hardest part, because the body is very easy to specify, because of course we can access the body from the class itself. So the body, we will just add a parameter to the interface to accept receiving a body.
Okay.
So let's say that the body should go first, and it's going to be a stream type, let's say content, and it's going to have a default value because that's how it started. So I'm using default parameters.
Okay. Yeah.
Okay. So now the method can accept any number of requests, any number of parameters, the stream content, and an optional query strings. So that quite nicely mimics the actual usage that you can do for httpbin.org.
Right. Okay.
And now, because I've got a body, let's take it from the HTTP request data itself. So it's just a matter of using rec.body, and that's how it does.
Right. Yeah. Okay. Yeah.
Maybe it's best if we can see this.
Yeah. You can actually see. Yeah. So the HTTP request data is our input argument, and that contains the entire request. So we're using the body parameter as our input there. Yeah. All right. Yeah.
So let's build it again. I think we've spent most time building the solution.
Rather than changing code.
Yeah, that's right. So let's test the running function with our favorite request. And now we've got the data.
Yeah. Nice. Very cool.
So I think that's the end of the exercise. If you'll allow me, I'd like to recap just a little bit what we've done here. So let me jump right here. So we were there. So as you should be now more familiar with those two calls that we've used in the dependency injection, in the program.cs actually. So the first one is the one that configured the HTTP client instance that is used internally under the hood. And the other one is where all the magic that refit brings is done. So basically that's how refit knows how to use this particularly configured HTTP client instance to provide a strongly typed experience around this.
Okay.
You actually could use only the first call if you wanted to, and that would still be an efficient usage of HTTP client. In that case, you would use it because you would like to have more control, or maybe the API is not easy to design in an interface. So that's always a possibility, and that's how you would use it. So basically, if you use the first add HTTP client call, this is what it gives you. It gives you a pre-configured HTTP client instance that you can use using an HTTP client factory. Because as you recall in my earlier explanation, I said that you should not instantiate the HTTP client yourselves. So that's what the HTTP client factory does for you. So basically, you use this interface, you inject that into your constructor, and then of course you can use it as you would. So the first thing that you would need to do is to create a client using the name that you've given to this particular configuration. And this will give you this particular instance of the HTTP client that has been configured. And after that, you use methods from the HTTP client class itself. So the var client here is an HTTP client.
Yeah.
But you can see that it's quite a bit of technical code to write. And it's best if you use an interface. So that's what the second call to add typed client does. It wraps this pre-configured HTTP client instance into a nice interface that you can use in your code. And so basically, as long as you provide a properly decorated interface, then you can use the code that has been outlined in the lesson itself.
Yeah, I think like you mentioned, if you have a really well-defined API or endpoint that you want to use, that doesn't very quickly change or something, then it's probably best to use this typed interface with this custom interfaces.
And I think it makes it easier for beginners to call third-party APIs if the interface is well structured and.
Yes, yeah, definitely, yeah. But maybe things are maybe more fluent or maybe heavily in development on the endpoint. Yeah, maybe then indeed you would maybe consider not writing an interface because the interface is changing every day or something, and so you might want to be better off at making raw requests or something.
And sometimes if you have like GraphQL or OData APIs, maybe it makes it a bit difficult to come up with an easy to use interface, and maybe sometimes you have to resort to using HTTP client under the hood. But for most, I'd say the majority of use cases that you'll encounter are best served with a strongly typed interface.
Yeah, I agree. Yeah. I definitely use refit quite a bit, and I always used interfaces. I never had the necessity or really using it without the interfaces. So I agree. Yeah.
So, how do you want to proceed further?
We are at 40 minutes now, so you had a bit more content prepared. I think we have time for that, so please continue.
Okay, so indeed, one of the best use case I've found for using Refit is when you actually combined multiple usages of Refit. So let me illustrate what I want to say here. So if you recap, Refit is just using is just providing for you a proxy implementation of let's say HTTP client, even though it uses HTTP client under the hood. For that, you need to understand that HTTP client actually uses a set of handlers which are stacked on top of one another in some sort of pipeline that we call, and those handlers are called middleware. And of course, when you use the stock interface, you only use one primary handler, and that's the one that talks to the actual endpoint over HTTP. But you could add as many handlers as you would like to let's say, add some logging capabilities, or more interestingly, to add some mocking behaviors or authentication behaviors. And that's what I would like to illustrate here. So how would you write that in C#? In C#, you've got all the code. So what you add to the two calls that we already know is we would add as many calls to add HTTP message handler with any particular implementation of such handlers to add capabilities to, sorry, not add capabilities, but add interception, logging capabilities, and so on. One particular use case that we can do, which is sometimes needed when you do some tests, is that you do not have the API yet. So you could use the HTTP client handlers for mocking purposes. So let's say that you do not have the endpoint, doesn't exist, so you can't call it over HTTP. So what you need to do is to come up with some sort of mechanism where you could actually use your HTTP client class without doing any HTTP calls over the wires. And for that, you are going to use one of the handler. So you need to shortcut the primary handler so that no HTTP calls is attempted. And for that, you need to write your own custom handler. And we'll use what we call mock handler. So that's just a particular way I named it, so that you can just shortcut the primary handler and provide a response to your client code without ever hitting the network. So the way to do that, handlers are classes that implement the delegating handler base abstract class, and that they provide a very generic method, which is send async. It takes an HTTP request message, and it expects to receive an HTTP response message. And of course, this is an asynchronous method. And what you do here is entirely up to your custom logic. So if you want to do the right thing, you do your logic, and at the end you call the base class. And here the trick to shortcut the primary handler is to actually not call the base class. Right. So you will effectively stop the pipeline right there. And it will return whatever you want from this method. So that's how you do mock HTTP calls.
Nice, yeah.
Another use case that we can use is to perform authentication. That would be one of the main use cases I've encountered so far. So you've got the httpbin.org API, nicely set up with a nice interface, but each time you call this particular API, you need to include some authorization header, for instance. And instead of doing that with cumbersome or clumsy code, I would say, you can do that right from the handler. So you'll use, for instance, the first handler as an authorization handler, and it will do the logic internally, so your client is not aware that authentication happens.
Yeah.
Your client code, I would say.
Yeah.
And of course, the authentication endpoint could itself be abstracted away as an interface that could also itself be implemented using the Refit proxy. So if that's the case, we will use the same pattern over and over as we've just done for http-bin.org API. And that's what we could use. So in our scenario, we do not have an authentication endpoint, unfortunately. So what we are going to do is we are going to combine the two mechanisms I've just talked about to mock the HTTP auth authentication endpoint that we don't have. So basically, a scenario that a real world scenario would look like this.
Yeah.
Right.
Yeah.
But in our case, we do not have the authentication endpoint, so we can't call HTTP here. Even though we have an interface typed HTTP authentication. So what we'll need to do here is use the mock handler trick to shortcut the primary handler. And so in that case, we would be able to use that in our case.
Yeah.
Shall we try and do that in the code now?
Yeah, definitely.
Okay. So I'm going to maximize this and switch to a version of the code that I'm using as a cheat sheet.
Yeah, no, I think it's very useful because it's quite common, of course, that maybe the organization you're working in has different development teams, and then you're working on this kind of API, and some other team is maybe working on the authentication API or some other API that your application is calling, but maybe that point is not ready yet. So then it's very useful to mock the expected outcome of the other API. So yeah, this is a very valuable trick to do.
Yeah. Thanks for that. Okay, so I think one of the first thing to do is to design our authentication API. So we're going to have a HTTP bin org, and let's say API auth. This is going to be an interface, and it's going to have a single method called post. And let's say we usually have something like auth2/token, make it a little bit more realistic.
Yeah.
And it's going to return, let's say, request token response class, and the method will say request token, and it will expect a request token request. Object. It's all a bit verbose, but it's all a very bit also explicit. So
I like that. Yeah.
I'm going to move that in its own file because I like to have all interfaces live in their own classes, in their own files, and I'm going to generate the request token response. So what we are interested in is only the access token, basically. So I'm going to have an access token, get set property, and for good measure, I like to explicitly use the JSON property name.
Yeah, so it's properly serializable and recognizable.
Exactly. I think this is just a bit redundant because this is how it would look like anyway.
Yeah.
But so here I'm using the system.txt.json NuGet package, which is built in .NET. So you already have it. It's already installed. Yeah. It's just that you can use it to serialize and deserialize JSON. And so by making it explicit like that, I make it aware to my to the people that read the code that this is how the JSON would look like. And at the same time, I would use a request token for the request. So of course, the request will most probably have a client ID, a client secret, and things like that.
Yeah.
Maybe we don't need it because we are actually going to mock that. But let's say that it's going to have grant type, and grant type is most likely going to be client credentials. But you can do whatever you want, and sometimes it's going to also have a resource or audience or a scope or any number of things that that you may need to have. So of course we are going to decorate this as well. So let me just quickly copy that to client ID, client secret, and type. Actually, this is not correct. It's going to be client secret.
Okay. Yeah.
It's going to be client ID. That's how it's serialized in the code, and it's going to be the source. Okay. So these are all we need to make an httpbin.org API. So now we need, of course, to have that injected into the dependency system.
Right. Yeah.
So let me just save this. Save it as well. So in the program.cs, we are going to need another one. So so let's go for it. So I'm going to create a new instance of add HTTP client. So I'm going to configure a second instance of HTTP client.
Yeah.
Let's call this one API auth. And basically it will probably look exactly as this one.
Right.
So maybe it's best to abstract away this code and to extract that into its own interface. So I'm going to say, let's configure this, and it's going to take an I service provider, and it's going to take an HTTP client instance.
Okay.
He likes to autocomplete things for me.
Yeah.
Does this sound right? It does. Okay, I need some namespaces. And therefore, I don't actually need this anymore. I can this away using configure.
Yeah.
And that makes it easy for me to reuse here. Okay. And after that, I can use an art typed client. It's going to tell me which REST interface, which interface Refit should use. And of course, I'm going to use the org API auth interface.
Yeah, so it's the new one we just defined, right? Okay.
So I think that's pretty much it. So now what we need to do, if we stop here, it's not sufficient because it assumes that we have a real authentication endpoint sitting somewhere.
Yeah.
Actually sitting behind the http bin.org because it's using the same host address.
Yeah.
So because that's not true, we need to create a mocked authentication handler. So the way to do that is to add a new call to add HTTP message handler.
Okay.
And you have to specify the type of the handler. So let's call it mocked authentication handler. And this class doesn't exist, obviously.
Yeah.
So I'm going to create it in a few seconds. But you also have to understand that we are going a bit above what Refit knows. So we need to inject this particular instance of the handler into the dependency system. So we need to add a specific call to either add transient or add singleton, depending on the case, with this mocked authentication handler.
Yeah, because we want to use this handler for,
exactly.
So Refit will use it, otherwise Refit will not know what or when to use it.
Exactly.
Yeah.
So that's how you shortcut the authentication. So let's create a new file. I like to have my classes sealed, and they should implement delegating handler. That's how. Okay, so it doesn't offer me to override. So let's say override. It should come with the methods that I can override, and that's the one that I want.
Yeah, right.
So this is the default implementation of a do nothing middleware or handler. In my case, I'd like just to shortcut the pipeline. So I need to return something anyway. So let me just quickly see how I did that. Yeah, I just need to return something. So, because this is pretending that we are calling the authentication endpoint, we are going to receive some HTTP request message in which we will have some client ID, client secrets, and then we will return a token.
Exactly.
So what we'll do here, we'll return a custom implementation. So we are going to say, okay, let's say we have a default. It's not a GET request response. It's a request token response.
Yeah.
Request response.
Yeah, there it is.
And we are going to say, okay, the access token is going to be something like
and have a GUID or a string or whatever.
This is my token.
Right. Yeah.
Okay.
Yeah.
I actually have a better one for the code that will sit in the source code in a few days.
Okay.
And that's it. What we need to do, we need to serialize that as a JSON object. So let me just copy code because that would be better for your viewers. So the JSON serializer is also one that comes from system.text.json, and that's how you turn an object, a C# strongly typed object, to a JSON string. And what we are building here, we are building an instance of what the return type expects, which is an HTTP response message, and we put the JSON response in it.
Yeah.
So that's how we actually mock the authentication endpoint, because we don't have an authentication endpoint in our case. So the second thing that we need to do now, we need to call that as part of each time there is a request going out with HTTP bin, we need to include some authentication, authorization header.
Yeah, because this needs to be called first, but we haven't configured it that this will be called first. Right.
That's right.
Yeah.
So what I like to do is that we should definitely make sure that authorization headers are specified. So what I'll do first, before we actually try and specify headers, I'll add a new handler, which makes sure that if there is no authorization header, it returns an unauthorized response.
Makes sense.
Okay.
Yeah.
So let's say that we need to add, let's say a mocked unauthorized handler. Well, that's going to be a handler that we need here as well. And we need to create this handler. So what this handler says, it says, okay, each time there is an HTTP bin call made, make sure that we include an authorization header, otherwise return 401. And this is mocked because we don't have an actual endpoint, and HTTP bin is a public API, so it doesn't respond with HTTP. So I'm going to copy this real quick as well.
Yeah, so let's assume the other team is making this endpoint and requires headers being set and those kind of things. So we're just mimicking what the other team will be building and will be delivering in the future. So that could be a good use case of this.
Yeah, that serves as a good use case as well for team collaboration, because you sometimes you create the clients even before the API is ready. So in my case here, I'm just making sure. Let's say, do I have a request header named authorization in my request? If it's null, or if it doesn't have a proper value, then it means that it hasn't been supplied. In that case, I just return an authorized response. So there's a bit of thing here. I'll explain this better in the text. But that's how you instantiate. Basically, the code that you could write is easier to understand like that, but you need an extra package for that. So.
Okay. Yeah. Sure. It's okay. Yeah.
I'll explain that in a little bit more detail.
In a markdown. Yeah, that's fine. Yeah.
The only thing important here to say is that if we do have an authorization header, that's fine. Let's proceed with the next handler in the list. Right. And probably the next handler in the list will eventually be the primary handler. And the primary handler of HTTP client does send a request over HTTP.
Yeah.
Okay. So I think we are in a state where we can actually test our code. So let's build our code. And let's issue a request to the outside world. So if I recap very quickly, each time there is a call made to HTTP bin, it will go through a check to test whether an authorization header has been included in the request. And if it's not, it will return a 401 unauthorized response.
Yep.
If it is, though, it will let the request go through.
Continue to the next one. Yeah.
And here we have an authentication, an authorization endpoint that we are not actually using at the moment, and we'll use it in a few seconds. But let's first test this.
Yeah, this is just to test if the header is being checked and validated, right?
That's right. Okay, so I'm running the code here, and I think I'm going to rely on my favorite call here.
Yeah, it's still building. Yeah, it's always VS Code's always a bit slower when you're also doing streaming and recording, but now it's there.
Okay, it's there. So let's send a request.
Yeah.
Oh, I've got that's interesting. So I've got a 400 from the Azure function, but the status code was indeed 401 from the API.
Yeah. Maybe, so this is maybe how refit handles the error, maybe?
Yeah, that's right. So maybe because here in my code, I was in the exception part, and I didn't. I didn't anticipate that, so I just made it.
We sort of hard code there the internal server error, which is the 500, and we're not taking over the status code from the.
So let's do a bit smarter this time, and I think we can do this, which is basically so HTTP response data create response is just a static call. Out of the request, I'm going to create an empty response shell, and I'm going to have the status code from the exception that refit is giving me.
Yeah.
And I'm just going to return that. So it doesn't include any body, but that's fine for our sample.
The status code is in this case enough, I think. Yeah. Okay. Makes sense. Yeah.
So let's just run this real quick.
Yeah, and this also shows you that you have quite a lot of control with this refit exceptions, and you can either modify
Exactly.
your response a bit more and either include more information to your clients. It is very useful. Yeah.
Exactly.
Yeah.
So the setup, the code is set up now, and now I do have my forward authorized code.
This is very good to see. Yeah, nice.
So now for the finale, let's go to actually implement an authorization handler. So
yeah, to hook them up together, right? Yeah.
Okay, so I'm going to use this here. So by the way, handlers have a particular order they need to be declared in.
Ooh, yes.
In this particular instance, doesn't make any difference either way. But you have to be aware that the first handler will be called first, and they will be called in sequence when the request goes outside, and when the response comes in, you will be called in the reverse order of your middleware, obviously.
Yeah, good point. Good point. Yeah, order is important.
So what do I have here? I think I just called it authorization handler, which is very easy. And of course, I need to add that as well here. So let's just do this. And the authorization handler doesn't exist either, so it needs to be created. So let me just go through this. So what do we need here? We need to actually, that's the same thing. It needs to implement the delegating handler, and it needs to override at least the send or send async method. Nowadays, async is the way to go. And so this handler is going to be called each time there is a request. And its purpose is to augment, to enrich the request with an authorization header that comes from the result of calling the authentication endpoint. So the authentication endpoint comes from one of the API, which is called http://org API auth endpoint interface. So I'm going to inject in the constructor this particular instance. Let's call this like this. And so that's the first thing, which means that we can actually call this authentication endpoint using this interface, and we can capture the response from this endpoint and add the header. So I'm going to say, okay, let's have a token request. Do request token request object, and it's going to have something in there, client ID, client secret.
Yeah, right, exactly. Yeah.
Okay, so we don't need that for our purpose, of course. And the rest will be to capture the response. Response going to be the result of the call to auth request token with our token request. And it's going to be needed to await that because this is an asynchronous method. So I need to add the async keyword here. It needs to be added here as well. And now that we have a response, we have two different scenarios. So in my scenario, let's say that a new response is when authentication doesn't work. So if it's null, I'm just going to do nothing. But if it is a real response, we will use that to extract the access token from the response, right?
Okay.
So I'm going to have the access token here, and I'm going to add this into the authorization handler header from the actual request. And this actually is not a string. it's an authentication header value object. So I'm just going to instantiate that. And it takes a scheme, which is the bearer scheme, and the token. So I'm just going to say, okay, bearer and access token.
Yeah, because there are different schemes to be used, but this one is probably one of the more well-known ones. Yeah. So now we're updating the request that comes through the pipeline with a token that we get from our mocked endpoint.
Exactly. So I think that's pretty much all we need. To illustrate further, I just would like to show a best practice that we have also. You can use iLogger authorization handler in your code. So iLogger is a generic parameter, and you can have one logger per class. So that's the same name of the class here.
Yeah.
And if you do that, you will be able to control whether this particular class provides some logging or not. So I'm just going to use the generic logger here and assign one to the other. So this would make it easier for me to provide feedback as to whether this call works or not.
Yeah, good call.
Okay. And I think we're pretty much done. So what I've done here is I have added a new handler in the pipeline, which actually makes a call to attempts to make a call to an authentication endpoint. It just happens that this authentication endpoint is mocked, but it is using the interface for real. And if the authorization header comes, this mocked and authorized handler will let us through, hopefully, and we will have our response. So let's do F5. So I think we're just running the code here, and we need to test it again.
Yeah, exciting stuff. Wow.
And because my code is so complex, it takes ages to compile. Okay, let's trigger this. So we do have a 200.
Okay.
And did we have a log somewhere? I usually find logs a pain to configure, but this will work better in the lesson that I will write in the source code in a few days. But that's just a matter of enabling. I think that's in the host.json somewhere.
Yeah, the log level. Yeah. Well, when looking at the response, I can definitely see it's working because we can see the headers now, right? We can see the authorization header, so we can see it actually did work because the bearer, this is my token, is now there. Nice. Yeah.
So that's about it.
Great. Yeah. Yeah, this was definitely a nice bonus with regards to the rest of the calling third-party REST APIs. But I think this is a very valuable one, right? Because it's quite often that you want to mock or fake something anyway.
I think it makes it just a bit more relatable to how we would actually use that, because it took me some times initially when I learned about Refit. But how can you combine? How do you use Refit? You have to do several calls in one.
Yeah.
So I think it's a bit nice.
Yeah, and to have authenticated endpoints is also very important to have. So yeah, authentication is definitely a very important point when calling third-party REST APIs. And so this was a very valuable addition, Maxime. Thank you.
And I think it's up to people now to use caching mechanism to not include the token every time. To not call the authentication endpoint every time. But that's just nice to add afterwards.
Yeah. We can still keep on extending this. Indeed,
that's right.
You're definitely right. Yeah, and there are actually some NuGet packages which can help you with caching these tokens anyway.
Yeah,
so,
that's right.
I'll try to find it and put it in the description as well. Great. Let me start sharing. Let's move your screen at least. But yeah, thanks a lot, Maxime. This was really, really
My
good
pleasure.
lesson.
I hope I didn't drag too much of the lesson too long.
No, well, I always add some chapters on for YouTube so people can easily move back and forth and skip certain things if they want. But I think it was a great overview. I'm a big fan of refit because it really helps me structure your REST calls. So I think it's very, very valuable. So it's good for people to know about this. Thanks a lot for your contribution.
Thanks for having me.
Definitely, and if you find another topic you are enthusiastic about, please do let me know. For happy
Sure.
to cooperate with that. So yeah, thanks everyone. I hope you enjoyed this lesson. Please let me know if you like this, and also please subscribe to the YouTube channel. If you want to collaborate on a lesson or have feedback on lessons or request lessons, please head over to the GitHub repo. Again, this is the URL for you to use. You can raise a content issue there if you want to help or ask for new content. And please reach out on Twitter. Until next time. Bye-bye.